Right, we're going to talk now about bearings and their relationship to trigonometry. Now, bearings, when we talk about bearings, we're talking about direction, north, south, east, west. North and south, comfortable with that. North, up, south, west, off here, and east this way. Now, if we're going to walk on a bearing of 100 degrees, then bearings are measured in this direction clockwise from north. So let's just make that note there. Bearings are measured clockwise from north. These are true bearings. So if I was going to walk on, so if this is my starting position, it's always good to start right at the origin. If I walk on a bearing of 100 degrees, then I need to measure 100 degrees around from my north. Now that's north there, so 90. So I'd be coming on this little angle here, wouldn't I? Where that and there was 10 degrees. This would be a 100 degree bearing. Okay, so that's bearings, always clockwise from north. Okay, so let's have a look at a couple of little problems. I'm going to set up another north, south, east, west here, and put down a few points. So that's not my west. That's my east over here. My south, my north, and west. Okay, I'm going to set up a few points here. So we'll pop an A out here. That point A, and this is 35 degrees in here. So I'm just going to whack down some points here. So this is C over here, 30 degrees in there. Going to give you a 70 degrees there and a D. Now these are just some examples from the textbook, but given that information there, we're given two tasks, and one is to find or give the true bearing. I beg your pardon. All right, so example 1, question 1. Give the true bearing. Remember, the true bearing is clockwise from north. Give the true bearing of, firstly, O from A. Okay, so from A. Now the important thing here is we're going to keep going back to this, is that wherever you're taking the bearing from, that's where you want to, right, in this case A, where the point A is right there. What we want is we want to make A the center of a north, south, east, west grid. Because we're going to take our bearings, wherever we're taking our bearings from, we need that to be right at the center. I said right up here, if I was going to walk 100 degrees, on a bearing of 100 degrees from this point here, really easy to measure, because I drop it down here, because I've just got that 100 degrees around here from my north axis. So wherever we're taking our bearings from, draw a little north, south, east, west on it. Now, we want here the bearing of, O. O is here at the origin, right? That's O there. So O from A, really important, from A. All right, we draw A at the center of a north, south, east, west axis. All right, that's really important. It's just a point. Okay, so we draw that in. Now, where is O in relation to A? What's the bearing of O from A? All right, so we go up to our north. We go clockwise from our north axis, and we measure this angle around here, all the way around there. That is my bearing of O from A. So what have I got? I've got 90, I've got 180. I just need this little angle in here, don't I? This is a right angle. So now I'm going to use my knowledge of trigonometry and the sum of the angles of a triangle, giving me 180, 90 there. So 35. This one in here must be 55. 55 and 35 is 90. So I've got 180 plus 55. So the bearing of O from A will be that 180 plus 55 equals 180 plus 55, which equals 235 degrees. Now we always give our bearings in 3 digits, so if it's only 2 digits, like 35 degrees, I'd write it as 035. 235 degrees is my bearing of O from A. Let's have a look at another one. Question 2. I give the bearing of O at this time from D. So from D now. So I go up here to D. This is my point D. So I'll put a north, south, east, west on D. Good idea to go far enough to cross the red axis, the original axis. Right, from D, I want O from D. So I join D and O if they're not already joined. And now I measure from north, there's my north, right the way around here to my line that joins D and O. So this is 90 plus this angle in here. I don't know what this angle in here is yet, but that's 70 degrees there, which means that that's 20 because that's a right angle. So I've got 20 degrees in there. And if that's 20, this is a right angle, that's 70 degrees there. Or you may have already done alternate angles, and I'm sure you have. These are parallel, aren't they? These, what you get with north, south, east, west, lots of parallel lines. So parallel lines there, and we've got one of these Z angles or alternate angles, 70, 70. So that's 70, so my bearing will be 90 plus 70, which is, so it's equal to 90 plus 70, which equals 160 degrees. So that's 160 degrees right around there, 160 degrees. Just as this one here was 235 degrees, 180 plus 55. Okay, so that's the way to, let's perhaps do one more. What's the bearing of, let's say the bearing of C from, let's say the bearing of B from, oh no, that's going to get too complicated. Let's go with the bearing of O from B this time. So the bearing of O from B. From B is the key word there, from B. Whatever we're taking the bearing from, put a little north, south, east, west with B at the center. Okay, so we're going with O from B. Now we're going to go from north all the way around. 90, 180, 270 is to there. What's this angle in here? That's 90, 45, 45, or you could use alternate to get that in there as 45. Use those alternate angles a lot here. So we're going 90, 180, 270 plus 45. So O from B is equal to 90, 180, 270 plus that 45 in there, which is 315 degrees. Okay. Right, let's move on to another example on bearings just before I leave you to get on with the work requirements. And this will be, I'll just copy this example down and then we'll get back to the working out for it. Right, so let's have a look at this question. A ship travels due south for 5 kilometers. So let's draw that little trail of the ship going 5 kilometers to the south. There's its starting point. All right, starting point there. Starting point, and then now the ship is here, then on a true bearing of 120 degrees for 11 kilometers. So from there it changes direction from due south to 120. Now 120, remember, is measured from north. Right, it's now here, so if it goes 120 from here, it's going from north 90, about down here somewhere, isn't it? 120 down here somewhere, where, right, if we draw a, all right, that's an east-west line there, and this is my south line there, and that's my north line. That's going to be 30 degrees in there. That's 90 degrees obviously there. So the ship's gone due south, then on 120 being that angle in there being 120 degrees. Now let's have it over to the question for 11 kilometers. So that's 11 kilometers there. Distance. Now the question here is find how far east the ship is from its starting point. Now there's its starting point. It's now there. How far east is it of its starting point? What we need to do with these questions is to complete some right angle triangles. Now Right, at this point here, it's as east as it was to start with. It's gone directly south. Now it's gone on this bearing. It's travelled east a little bit and south a little bit. How far east has it gone? That's how far east it's gone there, x. So x equals distance east from starting point. Distance east from starting point. And if we're interested in distance south from starting point, well, it's that 5 plus that bit there or that bit there. So we would say that y is equal to the distance south from starting point. And we would find this distance by using some trigonometry. So now here's my little triangle. I've got 30 here, I've got 11 here. I want to find that distance there, x. So what am I using? I've got SOHCAHTOA at my disposal. I've got a right angle triangle. Think about that and try and answer the question before I do. Maybe pause the video. I've got, which side is this? This is my adjacent side. I've got my hypotenuse. I'm working with the adjacent and the hypotenuse, SOHCAHTOA. I'm going to use cos. So my solution is going to look a bit like this. Cos 30 is equal to x over 11. X over 11. So x will equal 11 times cos 30. And 11 times cos 30 is, if we go back and open up a calculator, 11 times, get my calculator out, cos 30, and I'm in exact mode, but that's 1.69. I wonder if I am in the right setting. Document settings. No, I'm in radians, so I want to be in degrees. So make sure you are as well. And go back in here and try again. 11 times cos 30. Hit enter. If you need exact, control enter will give it to you. 9.53 to 2 decimal places. 9.53 kilometers to 2 decimal places. Now, if we wanted to find y, we'd be working with the opposite over hypotenuse, and you'd use sine for that. Okay, let's do exercise 4D now from the from the work requirements, and that'll lead into our trigonometry test on Thursday. All right, I'll see you soon.